Okay, so I'm gonna just show you a little bit about text generation. And what I'm gonna use for text generation is something called a Markov chain. And a Markov chain is basically a way of representing text as a series of probabilities. So here's an example. So you take a text, which could be anything, could be just like a text file or something with a bunch of sentences in it. And then you figure out, if I start at the first word, what's the probability that the next word will be X? So if I start with good, what's the probability that the next word will be morning? What's the probability that the next word will be day? What's the probability that the next word will be something else? So the idea is you take a text and then you figure out the given word A, what's the probability that the next word will be whatever. So if I start with Mary, in this example, there's 100% probability that the next word will be Christmas. If I start with happy, there's a 2/3 probability it'll be holidays, and then new, and then year. So I could take this tree, and actually I'm gonna go right here. And let's see if I can copy this over easily. Just do that. Not quite. All right, so I'm going to take a screenshot. All right. So then I've got this this screenshot right here. I'm gonna split. Sorry, one sec. All right, I'm gonna split this down. All right. So here's like a model. So if I were to reverse engineer this model to the original text, I would have something like good morning, good morning, good day, Merry Christmas, Happy Holidays, Happy Holidays, Happy New Year. So something like this. So if this is my actual text, then I could represent this as a Markov chain here. Any questions about that? I'm not expecting anyone to become experts in Markov chains or anything like that. This is just kind of a silly example. Any questions? Okay, so what we're going to do now is we're going to make a program that will read in some text file, and then we're going to create basically this tree. So if we're not going to use a tree directly, we'll just use a dictionary. So we'll create a dictionary, and then every word in the text will be an entry in the dictionary. And then the corresponding value will be a list of any word that occurs after that word. So for example, if I were to represent that is, I'll call it lexicon. It would be something like this. I would have good and then morning. I'm not gonna use quotes here, but morning, day. I don't know what it's supposed to be. And then the next one would be something like Mary. And then that one would just have Christmas and so on. So we start with the text and we can either represent it as like a tree, or we can use some other structure which gives us the same basic information as this tree. So we're going to end up with something like this. So this is, we're going to take a text, just a raw text file, and we're going to turn it into a lexicon that's going to be key value pairs like this. Okay. So I'm going to do this. All right. Does anyone have any, does anyone want to have like a favorite novelist that I can find on Gutenberg? Something in public domain from like 100 years ago.
Edgar Allan Poe.
What was that?
Edgar Allan Poe.
Edgar
The
Allan
poet.
Poe. Oh, yeah, I'll do Edgar Allan Poe. Let's see, works. We'll try to get a plain text. All right, cool. So I'm going to grab this. Cool. And I'm just going to delete some of the boilerplate beginning and end. Cool. So just a little bit of cleaning. So we have this text document and we want to turn it into, you know, a lexicon, something that's structured like this. So for example, we would go through and look at every single word and start with cot. We would add cot to our dictionary, and then what's the word that happens after cot? From. Okay. And then we go to from, and we add that to our dictionary. What comes after from? Some. We keep going over and over and over again through every single word in the text. And so we'll start there. So let's build that first. So I'm gonna hi. I'm gonna create a class to do this. So class generator def init. So we're not quite sure what we're gonna pass in here. So we know we're gonna have to do a few things. One, we're gonna have to read in the file. So I'm gonna write that. So def read file. And I'm just gonna read this in directly. So with open source.txt, and that will be in read mode. That's F. This is the file handle. I'm gonna do text equals f.read. So I'm just gonna read in all of the contents as just a string, and I'm gonna return text. Okay, so now I'm gonna create a I'll just call it run, and then I'm gonna call self.read file, and I have assigned this, so I'm gonna do text equals this, and then print text. All right, and then just to do some initial testing, I'm going to create an instance of Markov generator, and then I'll call the run method. and we will see what we get. Okay, so a whole bunch of text as we expect. So that's good. So if you ever are interested in like natural language processing or machine learning or anything like that, one thing you will definitely have to do is clean stuff. So this raw text is actually there's too much stuff in here. We want to simplify this so it just makes our model a little easier to work with. So you know, if a word occurs in uppercase or lowercase, like it, so do we want to have two different entries for it with a capital I, it with a lowercase I? No. So I mean, this is a decision you can make, but we're basically going to simplify it. So we're going to remove all punctuation and we're going to make everything lowercase. So to do that, def get clean text. And then I guess I can pass in the text here. And then I'm going to, so what I want to do ultimately is create a list of this text. So this raw text, I'm going to split it by space. So it's a list. So I'll call it words equals raw text dot split. And I'll split by space. And then cleaned. So I'm going to call a function. It's going to be the cleaner, def cleaner. Sorry, I'm just going through this quickly. So cleaner is going to take a word. So self.cleaner word for word in words. So what I'm doing here is we're going to read in like basically the file as a giant string. We're going to split the file by space into a list of words, basically. And then we're going to clean all of those words. And clean, in our case, we're going to make everything lowercase. So I'll do that. Word equals word dot lower. And then we're also going to remove punctuation. I'm going to import regular expressions here. Word equals re dot sub. So I'm just going to remove punctuation. So I will look for anything which is not A to Z. Yeah, we'll do this for now. Maybe we can adjust this later. And I'm going to replace that with an empty string. And what I want to pass in is the word. Then I'm going to return word. All right, so we'll try and run this. So I'm going to get the raw text here. I'll call this raw text now. Then I want to call get clean text. And I want to pass in the raw text. And that should return clean. Actually, I'm going to make this an attribute. So self.cleaned equals clean. Okay, so I call the run method, and now I'm going to look at print mg dot. All right, so if I run this, okay, I got a bunch of stuff. Yeah, so I'm also going to go ahead and filter. I'll filter out empty strings. So so cleaned is this. Oh, yeah, let's do another filter. So filter empty equals the word for word in cleaned if word does not equal an empty string. Let's try this again. Okay, we filtered out the empty word. So now we have a list, a giant list that kind of represents our text, but it's, it's a processed version of the text. So now what we want to do is we want to go through and we want to start building our dictionary. And the process for that, again, is we start at a word and we look at the one after it and say, what is that? So we want to build a list of key value pairs where every word here is a key, and then eventually every other word that occurs after it will be part of a list. All right, so let's do that. So def.
Deal with words that were combined just because of the punctuation in the original.
Yeah, so there's definitely lots more we could do if we wanted to improve this. This is just like the most basic thing we can do right now. But yeah, there's splitting by string, for example. Is this the best way to get word boundaries? I mean, it's like 90% of the time, yes, but there are plenty of cases where that's not the case. We'll just keep it simple for now. All right. So to build the lexicon, what we want to do is I'm just gonna look at gonna cheat for the sake of time. All right. So I'm gonna pass it, or actually we have access to the cleaned text basically. Self.cleaned. So let's iterate over every single word in this list. So for I in range len self.cleaned. And so we want to iterate over every single word, but we want to get the word after it. So if we get to the end and we look for the word after it, we're gonna get an error because there's nothing there. So we're gonna have to shorten this, so -1. So now we can iterate over every single element here, and I'm gonna start building a dictionary. So I'm gonna make this here. So self.lexicon equals, make an empty dictionary. And we're gonna have two conditions. So if the key doesn't exist in the dictionary yet, we're gonna add it. If it does exist, then we want to look at the word after it and add it to the corresponding array. So those are our two cases. So if self.cleaned at I in self.lexicon. So that means this entry already exists in the dictionary, so we need to add the corresponding word to it. So self.lexicon at self.cleaned I. So this is the current word that we're on. We're going to add this to the dictionary. We're going to append self.cleaned at I plus 1. So if for example his, or let's do regard, if regard is already in our lexicon, then we don't need to add it because it's already there. So what we're going to do is look at the next word, which is I plus 1, in this case his, and we're gonna add it. So the dictionary at this point would look like regard And then let's assume that we have a bunch of words already in the dictionary from earlier in the document. So now we're just going to add his to the list. Okay, so that's one case. The other case, else we're gonna add this to the dictionary. So self.lexicon, copy this. We're gonna create the entry equals. We're actually gonna grab the same thing, except we're gonna have to create that list the first time. So if this were the first time that regard had showed up, we would have regard, we added the key, and then we just do his. So we create that list, and then we populate it with just that first thing. So those are the two cases, and then after that, we should be all done, and we should have a lexicon. So let's check that out. Self.build lexicon. And then I'm going to print the lexicon. Let's see what that looks like. Okay, so it looks like this is working. Let's see if we can find an example where there's more than one word. For example, so streamed, so streamed down or streamed terribly. So it looks like this is working. So we've taken our text, we've cleaned it up to basically regularize it, to make it simpler to analyze. And then we've created this lexicon, which is basically a representation of the text, which shows you a word and then whatever words follow it in the text. Any questions so far? Sorry, this is a little fast, but this is also like, you know, just for fun anyway. Okay. That's fun for me too. Okay, so we have this Markov generator. We've now built our lexicon. So now what we want to do is we want to generate text. And how do you generate text given a big thing like this? Given this lexicon, how do you generate text? Well, you start with a word, for example, almighty. So I look up almighty in this dictionary, and then what do I have in the list? Well, you know, there's lots of sophisticated things. We'll just keep it simple, and we'll randomly choose one element in the list. If I randomly choose one element in the list, we get God. And then I would go and I would look up God as a key, which should also appear in the dictionary. And I would go there, and then I would see, okay, let's just say it's rigging. So I look in the list of values, and I choose one at random, and I grab that, and then I look that up. So you can just keep going, and you look up something, you choose one of the words that could follow it, you add that, and then you go look that word up. And you can repeat that process as long as you like. You can get as many words as you like. Yeah, so that's the basic idea. So def generate text self, and I'm going to pass in the number of output words. What we're going to do is we're going to have a starting word. So I'm just going to hard code this for now. I'm going to do, I'll start with something that's simple, like he. So we can make this more dynamic later, but for now, I'm just going to hard code it. And then we're going to look up key in our lexicon. So text word equals self lexicon at starting word. So this will actually be a list, and then we can randomly choose one of those. So I'm going to import random. And there's actually a convenience function which allows you to randomly choose one item out of a list. So random dot choice. Okay, so I start with the word, for example, he, and then I look that word up in my dictionary, and I get a corresponding list of possible words that could be next. I randomly choose one of them, and then I could just kind of keep going. So that's the basic idea. So I'm going to start here, and then I'm going to loop over. So for I in range words plus 1. Text. So generated text. Let's see if I start with a starting word. Maybe I should make this current word. I'll call this current word. Okay, so I'm going to add this. Yeah, this is a little janky, but that's okay. So generated text plus equals word. I get the next word, and I will concatenate that. So generated text plus equals space plus next word. And then let's see. So I'm going to keep looping, and I need to change the current word to whatever this next word is. So current word equals next word. And then ultimately, I will return the generated text. Let's see, does anyone see anything wrong with this?
What is num words again?
This is basically like how many words you want to get. So how long of a random text do you want to get?
Oh, okay. Okay.
All right, let's run it and see what happens. So instead of printing the lexicon, I'm going to do mg dot generate text, and let's do 15 words. Okay, so I get he left, below him, downward, upward years to me, no remedy would assist me, and often. So this is not like, and if I randomly do this again, I should get a slightly different thing. So I start with he, that's hard coded, but boasted acumen of the single individual for the heavens and what limit beyond my hand through. So it's obviously like kind of nonsense, but it's not totally random nonsense. And this is like the most basic way to generate text. And so even the simplest thing is actually like not too bad, actually. I think. Use it as a way of paying any time. Yeah. But anyway, so you can keep doing this and keep generating random text, kind of based on the input you gave it. All right, any questions about that? All right. So now now we want to do is we want to, we can run this locally and, see it on the console, and that's great. But what we really want is to put this up on the web somewhere, and then to use this, we want to build a website which can actually get a random text chunk. So that's what we're gonna do now. So we have the server. I'm just gonna copy actually what we just did. Okay. Where is that? Get that. Okay, so now we have our server here, and what we want to do is use this to create a JSON response. So how am I going to do that? Well, I'm going to import this class first. So from Markov imports Markov generator. And then instead of time, I'm going to make this random. We'll call this random O. And then this build JSON response instead of this. So random text. And what am I going to do here? Well, I want to get a random text. So I'm going to create the instance. I'm going to call run on it, and then I'm going to get the random text. So mg equals Markov generator mg.run. And then when I actually want to get the text, I can do, you need to call string on it, mg.generate text. And I pass in the number of words. We could get this dynamically, but I'm just going to hard code it. Let's do 20. Okay, so let's test out our new API. So I'm going to run this, Python server.py, and I'll use Postman. Localhost 9292, except not time. It's going to be random. And now I'm getting this from, so random text, blah, 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 blah. Okay, so we just wrote a program, and now we've kind of made it consumable as a web endpoint. So now we can include this in, an HTML page. So actually, I'm just gonna copy over the rest of this just to show you real quick. So this will now be Po, and maybe I'll do something more, slightly more complex here.
If you wanted to, could you have turned the entire dictionary that you generated into a JSON file and then used JavaScript to create the random sentences?
Yeah, you could. That's a lot of, it's a lot of information to pass. In general, you want to offload work to something else, like the server. The server is probably the best place to do that kind of processing, and that way the front end doesn't have to be smart. The front end can just like give me the information and display the information.
Cool.
But yes, you definitely could do that. Yeah, I'm just gonna do this for now because I don't want to spend a lot of time. So I'm gonna run this with live server. And there we go. So now, you know, we're viewing this as HTML. I'll make another request to get another random thing. Is this doing that same? There we go. It's taking a minute to process. Yeah, must be some bug or something there. It's like every other request is going through.
That's Edgar Allan Poe. It's hard to read.
Yeah, I can look into that. I'm not quite sure why that would be happening. But so yeah, so there's some kind of bug there, which I can look into in a second. But the real point of all this is to have us be able to package this up in a container, and then, or you know, in an image, and then push that image up to Docker Hub so that anyone around the world can just pull down our API server and use it. Let's do that. So I'm going to do here is actually, let me get rid of this for now. Actually, I'll leave it. I can show you the Docker if you want. All right, so I'm going to create a Docker file. And how do we Dockerize stuff? Well, let's look at our application. So, you know, our application, the stuff we need to run is actually going to be both of these files. So server and Markov. So first thing, what do we need in order to run these two files? At a minimum, we need Python, right? Are there any third-party dependencies?
Would the text file or the where you got the text from, would that
Source
be
file? Okay, yeah. So yeah, we definitely need that. So we need to include these files. But in terms of like the virtual machine, does the virtual machine need anything else to run our program other than just Python?
Like all the stuff we import, don't they need those too? Or
Yeah.
do they just come with Python?
Yeah, so that is a good question. Can anyone try to answer that?
I would think that if you're importing Python, you get all the libraries with it. And it should buff.
Yeah, so this stuff is all coming from the standard library. So this is available in Python, you know, automatically. So we're not like, this isn't a third-party module that we're, you know, having to download or anything. So all this stuff is built in. So yes.
If we were to download like pandas or something, we'd have to go through like a little bit different of a process.
Exactly. So we'd have to, if we, so I'm gonna, so for one, we have a pretty simple Python application. So we shouldn't need very much. So I'm gonna do Python. So I'm gonna go to Docker Hub, Python. So I can just choose a random one. I think I'll choose, you know, it doesn't really matter, but I'll choose an Alpine one just because it's smaller. And the version of Python probably doesn't really matter for our case, but I'll choose 3.10. So Python : so Python is the image name, and then this is the tag. So this is the more specific version. I'm going to import that, and then so I now have another computer, and it has Python installed on it. So what else do I need to do?
Is this where you need to make a working directory to put everything?
Yeah, so you definitely, you don't have to, but yeah, if you want to structure your virtual machine, your container, your image, then yes. So let's do that. So work there, and then this will be, we'll just call it slash, we'll do it slash my app. I think. Forget if you have to give, we have to give it do something like that. Okay. So we create a working directory. So now we have a virtual machine. We have Python installed on it, and we have a folder called my app.
Now we need to dump everything into that folder.
Yes, exactly. So how do we do that?
With the copy command, and then not really sure.
Yep. So good. So copy, and then source destination. So there's a few things we could do. We could copy, if I do copy dot, that means copy everything from the current directory into basically the working directory of the virtual machine. So we could do that, but we don't really need this app.js or index.html. So we have a couple things we could do. We could be more specific with what we import, and we could also we could add something called so we have a git ignore, right? So if you have git ignore and you want to create a git repository, there's a few things I don't want to push up, so I can include those. There's also a Docker ignore, which does the same thing basically. I'm just going to create that Docker ignore, and I'm going to put in app.js and index.html. So now I can be lazy and just copy everything, and it's going to automatically exclude these two files that I don't need. Okay, so now I have a virtual machine with Python installed on it. I have a directory called my app, which now has source.txt, server.py, and markup.py in it.
Now you need to start the server inside the.
Yes, so I think now we've basically described, we've completed describing the environment that we need. So what we have to do now is figure out, well, what do we do when we run the container? What do we want to do? I'm gonna call on someone else here. We pick on Joyce. Joyce, what do we want to do now that we have a virtual machine? It's got Python on it. It's got our program on it.
We want to give it a command to run.
Yes. Yep. So cmd. And what's the command that we want to run?
I'm not sure.
Okay. What command have we been running locally to run it and test it?
Just a Python server.py.
Yep, exactly. So you should just, how did we run it locally? Well, Python server.py. Okay.
So could you have it to where if you did not have that command there and someone like downloads your container from Docker Hub, they would just manually start the server themselves?
Yeah, you could do that. So they would just have the container and it would just kind of sit there. And then what you could do is you could do you could like connect to it with bash. So you could exec in with bash and then run the server manually.
Cool.
Okay. All right. So now we have this Docker container. So we have described our application. We've described the dependencies that it needs to run, and we've described what we want to happen when you actually run it. All right. So we have the description, but now we need the actual thing. How do we get an actual container?
Is it building the image?
Yes, yeah, we have to build it. So I'm going to do that here. So Docker build and then dot. So this is the minimal command that you need. So Docker build, and then you need to give it a Docker file. And it's smart enough to know that in the current directory, there's just one Docker file, so it's going to automatically grab this one. So you could do that. I'm going to give it a name just to make my life a little easier. So -t. And what I'm actually going to do now is I'm going to give it a name that matches my, because ultimately I want to push this up to Docker Hub. And if you see like the official images, if you look at Python, the official images, notice the URL starts with underscore. So this basically means these are official images. This is like the namespace for official images. So you can just do Python. But if you're just a random schmuck using this thing, like all of us, you don't get that special namespace. It's going to be on your user account. So I'm going to name it. This is I forget what my Docker Hub username actually is. Let me log in. Yeah, so Chad Mowbray. This is my Docker Hub. So this will be just like your GitHub handle. You have a Docker Hub handle. So Chad Mowbray / and then I'm going to give it a name. So I'm going to do random. Oh, I'm going to call it random poll. So I build it. Oh, I need a space there. It takes a second, several seconds. All right, so now I'm gonna do Docker images to see if it's actually there, and it actually is. Okay. Now, I'm gonna go ahead and try running it just to make sure that it actually works. So how can I run an image?
Docker run in the name of the image.
Okay, so Docker run, and then I can do this. So what happens if I run this? I'll just go ahead and run it. If I run it.
It creates an instance of the image.
Yep. Docker. Yes. I can see that I'm running this, which is really cool. It's a web server though, right? So ideally, I would be able to connect to it and make requests to it.
Curl.
Curl, okay. So let's do curl localhost 9292 / random
You have to change the port.
Yeah, so what's happening is that like my container is running and it's actually listening on port 9292, but it's listening on port 9292 in its own Docker network. So my host machine network, there's basically like a firewall. You know, there's these two things are just operating on separate networks, so there's no way for them to connect to each other. So if I try to use my host machine to connect to my Docker container, I can't do it. So when I run, I'm going to stop this right now. So when I run it, I need to be a little bit more specific. So how can I be more specific?
You can use a -- publish flag.
Okay, so -p is the port flag. So this is the port mapping.
Yeah. So Docker run -p,
Uh-huh.
and then give the name of the port that you want to publish it to.
Okay.
And then the port that it is running on in your container.
Okay.
And
so I'm going to randomly choose port. It could be the same one, but doesn't matter. And then this is the internal port that it's listening on.
Yeah.
So our application is running. It's listening on port 9292. I'm going to map my host machine. So if I go to localhost 9894, it's going to map that to 9292 on my container. Now I'm going to run this. And if I'm going to make a curl request now, but I'm not going to go to 9292, I'm going to go to 9294. And that is not working.
98, 94.
I think when you
Oh,
ran it,
oh,
it
sorry.
didn't finish running.
Thank you. Is 9292 the correct port? I don't think. Yeah, it must be. Okay. So I guess I just confused myself by choosing a different port, but whatever. So it works now, right? So it doesn't matter really what port this is. It could be the exact same one. I just chose a different one for the sake of showing you. So I can make requests. So I'm making HTTP requests to my container. Okay, so it's working. So I've tested the application locally, it works. I've containerized it, and then I've tested the container locally, and it works. So I'm pretty sure that this works now. So I'm going to do Docker PS, Docker PS-A. This is all the stopped containers. So I'm going to just remove these individually. So Docker RM, oops, Docker 0C, and I don't have to pass it the whole thing. It should know that that's enough, and then C5. And if I do Docker PS-A, those are gone. So I just cleaned up those containers. Okay. So I now have a containerized application. So now I want to push this up to Docker Hub so that other people can use it. And it's actually pretty simple. Just like you can push up stuff to GitHub, you can push up stuff to Docker Hub. So Docker push, and then I'm gonna give it the image name. So Chad Mowbray /random po. And this will push up the image to GitHub. Then I'm going to go to my GitHub account or Docker Hub account. One sec here. Okay. And you can see in my account that I now have this random po image here. So now anyone in the world, including any of you, can do Docker run Chad Mowbray /random_po. So So if you guys want to try that now, there may be some issues. So Docker is very magic, but there are issues with the new Mac architecture. So I built this on an older Mac, which has the Intel chip. So does anyone want to give running this container a try? You can actually just execute. Where's that command? Let's do that here. Anyway, you can do Docker run, and then the port flags, whatever port you want. Something like this. Is anyone able to run it?
Is the port mapping always necessary?
If you want to connect to it, yeah.
Okay.
You don't have to, the port could be the same, but you have to supply the mapping, otherwise it won't know how to connect. Yeah, just let me know when you get it running.
So you said I should just be able to run it with that command.
Yep, you should just be able to enter that command. So Docker, if you try to run something that you don't have locally, it will first basically, it will implicitly run the build command first. So you should just be able to run that and it will take care of everything. So I want one example of someone with the new M1, M2 chip to run it, and one example of someone with the old version.
I got a warning I put in chat when I tried. I don't know if I did it right.
Okay, so do you have an M1?
Yes, I think so.
Okay. So what is the warning?
I put it in chat. It's the
Oh.
requested images does not match host map.
Yeah. So that's I'm not seeing it. Maybe my internet's being wonky. I'm not seeing it. Did you post it in the Echo channel?
Just in the Zoom chat.
Oh, okay, I see. Can you post it in the Echo channel? Cool. So that's what you should see. There's a way to fix that, and I'm going to let you guys figure that out. Is anyone able to get it running with the Intel chip?
Yeah, I think I got it running on mine.
Okay. So you have an older Mac or do you have a Windows machine there?
It's a older Mac.
Okay. All right. Good. So the hitch, you'll have to. I'm going to show the challenge for today. Yeah. So the challenge will basically be you will write something. It could be, you know, it doesn't have to be anything. It could just, frankly, just put some random JSON in there. But you're going to create a server with an endpoint that's going to return some kind of JSON. And then you're going to Dockerize it, and you're going to push it up to Docker Hub. And then everyone's going to do that. And then after everyone does that, everyone's going to write a front-end application that will consume at least 2 of your fellow students' APIs. Or I guess we can start with 1. So, you know, at minimum 1, but if you want to do more than 1, that's fine. And then here's the note for that error: warning, the requested images platform does not match the detected host platform. So you, as the person creating the image, are going to have to handle that. You're basically going to need to push 2 versions. One for the normal, like basically whatever architecture you have. So if you have an M1, you can just make that the default. And then another image with a different tag will be for the other architecture. So you can look through the documentation and do some search to figure it out. You guys can also share that knowledge with each other on Slack, but yes, that's the challenge for today. Any questions?
So we want our API to actually have some useful data in it then.
It doesn't really matter. It's up to you. Don't spend like 3 hours trying to make something. It doesn't, you know, the point of the exercise is to go through the whole process. So what you actually return can be, I mean, you could just hard code something if you want, at least to start with that. If you have an idea for something you want to do, that's also fine. It doesn't really matter. Okay. Yeah, then you guys can get started on that. So I would say, in terms of like planning, what I would say is maybe spend an hour or 2, maybe spend like, you know, an hour or something getting the server to work locally with whatever program you want to use. Spend another hour or so building and pushing up the image, and then you know, it's going to take everyone different amounts of time depending on what you do, but don't spend like 6 hours trying to come up with a program. So I'll check in periodically just to make sure people are not wasting time. Yeah. So everyone should be able to finish this challenge today, is what I'm saying. So make some kind of application, make it return JSON, package it up into a container, run the container locally, make sure it works, then push up your container to Docker Hub. And when you do that, just create, I'm going to do this right here. So that you can reply to that thread, which I will do now. And if you want to have a description, go to whatever slash slash random po. to get some random text. So you can post in the thing and you know, a description or any other special information that people will need to know to make it run. And then actually, I'll go ahead. I won't tell you how to do it, but I will push up a version that should work on the other architecture as well. So everyone just go through, do that. If there are any questions, let me know. For about the next hour, maybe hour and a half, I have a junk guy coming, so I have to move a bunch of busted up crap in my yard out to the front. So I'll be like not immediately available for the next hour-ish. But if you have questions, please ask. I will respond and I will be back after that. Okay. Yeah, you guys got Tiffany. So scare Tiffany, ask her your gnarliest questions.